Hello everyone, my name is Shubham Singh and in this session we are going to discuss questions on circles. Let's look at some of the questions. So first question says, in the figure given below, AB is equals to 9, AC is equals to 15 and BC equals to 12. A circle is drawn with BE as a diameter such that AB and AC are tangents to it. Find the value of the diameter. So in this question, AB is given to me as 9, AC is given to me as 15 and BC is given to me as 12. Let's take the center of this circle as F, and radius of this is X. So if this is X, this is also going to be X. This will become 12 minus X. Now for two triangles A, B and C, this is right angle triangle, and again one more FC. Let's take this point as to be K. Now this is, so FK is equals to X and FC is equals to 12 minus X. Now this angle is 90 degree and this angle C is common to both. So I can say that these two triangles are similar. So this will become 9 by 15 is equals to X upon 12 minus X. On solving it, I'll get 9 into 12 minus X is equals to 15x. 12 9s are 108 minus 9x is equals to 15x. This will become 24x equal to 108. X will become 108 by 24, which is 27 by 6, and this turns out to be 4.5. Now the value of x comes out to be 4.5. So the diameter of the circle will become 2x, that is 2 into 4.5, which is 9. So the answer to this question is 9 units. Let's look at the solution to this question. Moving on to the next question. So the question is saying PBA and PDC are 2 seconds. AD is the diameter of the circle with center O. Angle A is equals to 40. Angle P is equals to 20. Find the measure of the angle DBC. So for this question, angle A is given to me as 40. Angle P is given to me as 20. So I can say this whole angle will be 180 minus 60, which is 120. Or in other words, I can say this angle ADC is exterior angle to this angle, which is equal to sum of 40 and 20. Angle ADC will become 40 plus 20, which is 60. So angle ADC is 60. In other words, I can say angle ABC is also 60 degree. Why? Because the angle formed by the same arc is equal. So this is also 60. Now we need to find angle DBC. Now since AD is the diameter, so diameter subtends right angles at any point on the given circle. Angle ABD is equals to 90 degree. Now I need to find angle DBC. So angle DBC is equals to angle ABD minus angle ABC, which is equal to 90 minus 60, that is 30 degree. So our answer to this question is 30 degree. Let's look at the solution to this question. Moving on to the next question. Let ABC be a right angled isosceles triangle with hypotenuse BC. Let BQC be a semicircle away from A with diameter BC. Let PBC be an arc of a circle centered at A and lying between BC and BQC. If AB has a length 6 cm, then the area in square centimeter of the region enclosed by BPC and BQC. So I need to find the area enclosed by BPC and BQC, that means this area. I need to find this area. So for this question, it is given to me that AB is equals to 6 and it is also given to me that it is isosceles triangle. So this AC will also become 6. Now hypotenuse for this will become 6 root 2. So hypotenuse BC will become 6 root 2. Why? Because BC is equals to root of AB square plus AC square. So this will become 6 root 2. I need to find this area. So this is nothing but a semicircle of diameter 6 root 2. In other words, I can say the area of semicircle of which is pi d square by 4. This will become pi into d square. D is how much? 6 root 2 into 6 root 2 divided by 4. This turns out to be 2323, which is equivalent to 9 pi. So my area of semicircle BQC is nothing but 9 pi. So I have this area 9 pi. Now if you closely observe this thing, this is nothing but a quarter circle. So in other words, I can say area is equals to area of any circle is area of this circle ACPQ is given by pi r square by 4, where radius is 6 in this case. So area will become pi r square, that is 6 into 6 divided by 4, which is again 9 pi. Now area of this quadrant is 9 pi. Now what this area includes? This area includes the area of the circle as well. So if I need to find this part, I need to subtract the area of triangle from this area of quarter circle. So 9 pi minus area of triangle, which is equivalent to 9 pi minus half into 6 into 6, which is 9 pi minus 18. So area of BCP comes out to be 9 pi minus 18. Now if I need to find the area of this thing, I can say I need to subtract area of this part from the area of semicircle. So my answer will be area of semicircle minus area of BCP, which is 9 pi minus 9 pi minus 18. So this will become 9 pi minus 9 pi plus 18. 9 pi and 9 pi got cancelled. So our answer to this question is 18 centimeter square. Let's look at the solution to this question. Moving on to the next question. A circle touches all the three sides of the triangle as shown in the given figure at points P, Q and R respectively. If angle RPQ is 50 degree, find the measure of the angle BAC in degrees. So this angle is given to me, angle RPC, which is 50 degree. Now for such questions, always remember, whenever a circle is given to you, always take a point as the center. So I'll take a point O as a center. So this point RO and RQ are its radius. Now there's a property that, so the angle subtended by the arc at the center is double the angle subtended at any other point. So if 50 is given to me, I can say this angle is double of 50, which is 100 degrees. So angle ROQ is equals to 100 degrees. Now since this is radius, I can say these two angles are going to be equal. Angle ORQ and angle OQR are equal. So in other words, I can say angle OQR is equals to angle ORQ being the isosceles triangle. So this is going to be 180 minus 100 divided by 2 because both the angles are same. So this turns out to be 40 degree. Now if I take this point as 90 degree, these 2 points, so I need to find this angle ARQ. So angle ARQ is nothing but 90 minus 40, which is equal to 50 degree. Similarly, angle AQR is 50 degree. Now I know these two angles as 50. This is also 50. This is also 50. I need to find this angle. So in this triangle ARQ, sum of all the angles will be 180 degree. This will become 180 minus 50 minus 50. I'll get my angle A. So angle A will become how much? 80 degree. So my answer to this question is 80 degree. Let's look at the solution to this question. Moving on to the last question. Two circles are placed in an equilateral triangle as shown in the figure. What is the ratio of the area of the smaller circle to that of the equilateral triangle? So in my video related to triangles, I've described how in radius and circumradius and x radius we can derive. So I'm not going to discuss that part in this video. So we'll directly solve this question using in radius concept. So in radius to this circle, this is equilateral triangle given to us, and in radius I need to find. So in radius is nothing but a upon 2 root 3, right? So I need to find the diameter of this circle. So diameter is 2r. So diameter is equals to 2r. This will become 2 into a upon 2 root 3. So diameter of this circle will become a upon root 3. That means the value of this R and D, RD comes out to be A upon 2 root 3. Now I know the value of AD. Now before this, I've drawn this part as a tangent. That means PQ is a tangent to this circle, both the circles. Okay. So if I need to find the AR, so AD is equals to root 3 by 2 times of A. Now I need to find the value of AR. So AR is nothing but root 3 by 2 times of A minus A upon root 3. This turns out to be 3A minus 2A upon 2 root 3, which is A upon 2 root 3. So AR is again A upon 2 root 3. In other words, I can say AR is nothing but AD by 3 because this value is also A upon 2 root. So this whole value AR comes out to be how much? A upon 2 root 3. Now, since we know, or we can say we can derive these two triangles as similar. So this triangle APQ is also an equilateral triangle. So we can say that AR upon AD, I1 upon I2, where I1 and I2 are in radius of both the circles respectively. So AR we have derived. So this turns out to be I1 upon I2 is equals to 1 upon 3. So I need to find the value of I1. I2 I already know, which is equal to how much? A upon 2 root 3 upon 3. So I1 becomes A upon 6 root 3. So this becomes, that means the radius of this value, or in other words I can say radius will become A upon 6 root 3. So radius becomes A upon 6 root 3 for my smaller circle. So area of this circle is nothing but pi r square. This becomes pi A upon 6 root 3 whole square. So area of equilateral triangle is given to me by root 3 by 4 of side square. Now if I solve this, this will become pi a square. 36 into 3 is 108. So 108 is to root 3 by 4 into side square. The side square and side square get cancelled. This 4 is nothing but 27 times, which is 108. So the ratio will become pi is to 27 root 3. So our answer to this question is pi is to 27 root 3. So let's look at the solution to this question. So our answer to this question is pi is to 27 root 3. That's all for this session. Stay tuned with us for more such videos. Thank you.